Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo and today we have one of our students, Mariem, who has completed the course ROS Basics in 5 days. And at the end of this course, there is a project that you can test on a real robot here at The Construct that solidifies what you've learned in the course. So that is what we're going to be seeing here today. Hello, Mariem. How are you?
Hello, how are you?
I'm great. I'm excited to see what you've done with your project. So whenever you want, you can start sharing your screen and just explain us how you've accomplished what you've accomplished.
Okay. Can you see my screen?
Awesome. Yes, we can see your screen.
Okay. So I'll start by showing how the code works on the real robot.
Great. So we see the beginning of your program here.
Yeah. The robot will be trying to find the nearest wall.
The nearest wall, yeah.
I think something is not good here. Can I restart it?
Of course, of course. You can move it around, you can do whatever you want.
Okay.
Is it doing something strange? Something different?
Yeah, it's different than I've run it before, so I'm not quite sure why.
Well, it's still spinning right now. Is the server still running? I'm assuming, right?
Yeah.
So let's see if it finds it right here. It should twist a little bit more. That's weird.
It didn't.
And you've tried this code on the real robot, right?
Yeah.
Okay.
Just this morning.
Okay. Then don't worry. If this happens again, we'll try. There we go.
Okay. It found it now. So now it will be aligning to this wall. And then it needs to start the wall following. Okay. Now it will do a lap of the environment.
Okay. So it will follow the wall at this point. Oh, look at this turning. And what is that in the terminal that is outputting?
This is the feedback from the action. It's giving the distance that the robot walked this far. at this point, and at the end it will give the total distance.
I see. And let me ask you something. Is this
Okay.
movement that it goes and stops, does that happen in the simulation?
Uh, it didn't happen in the simulation, and also uh, it wasn't like this when I've run it before. This is stopping very often.
I'm trying to figure out why it's stopping. If oh, nice. Looks like
Yeah, there's a certain threshold between the initial position and where it got, and if it gets there, it will stop and give the final total distance and the list of the registered points.
awesome. So this is a list of all of the spots that the robot went through, correct?
Yes.
Great, and that's the last part. So that's nice. Now, if you don't mind, Miriam, do you mind if you explain a little more on how you achieved each
Okay.
of one of these? Oh, perfect. This is exactly what I was hoping for.
Yeah.
Great.
So I will be explaining how I've solved different parts of the project,
Mm-hmm.
the topics, the services, the actions. Um,
Okay.
so starting with the topics, first I had to create the package that will have all the code for this project. Then I needed other dependencies that I didn't know about when creating, so I added them to the XML file. And also I created a Python script that inside it has a subscription to the laser topic scan.
Mm-hmm.
I needed that in order to get the distance to the front wall and also get the distance to the wall on the right that the robot will be following. I also created a publisher on the topic command velocity in order to be able to control the motion of the robot.
Mm-hmm.
And at every step of this code, I will publish the velocity command that I need in order to get it to move fast from the front wall, and also to be able to not get too far from the wall on the right, and also not crash with it.
Mm-hmm.
Otherwise, it will move forward. I also created the launch file that will start this behavior, and I had to modify the setup.py to be able to find the launch files, and I added the entry point.
For your executable, yeah.
So the problem with this part is that I give certain command velocities in the simulation, and the robot used to function well without issues. However, with the same command velocities, in the real robot, they caused the robot to move too fast and it would crash with obstacles. So what I did is that I decreased the values of the linear velocity and the angular velocity. The robot seems to be very slow, but it performs as is expected.
Right, yeah.
Then for the services, I needed to create another package that will have the interfaces. I added the interface find wall, and then in the other package, I created the wall find script. What I did there is that I created a service server find wall, and in its callback, it would need to detect the closest wall by getting the shortest laser ray. It will rotate to face that wall in a loop that has a certain threshold. It would move closer to it by 0.3 meters, and it will rotate to be aligned with it so that the wall is to the right of the robot. I added a client to the service in the wall following software. I added sending requests to this service, and I created a main launch file that will launch both scripts. And of course, I added this entry point. So what I faced here is that when I test the wall finder separately with the terminal, it launches the service correctly. But when launching from the main, I had a problem that it wouldn't start. So I went through some discussions on the ROS community of the construct, and I've learned that I needed to make the callbacks as reentrant callbacks and use a multi-threaded executor. I did that in both scripts. I think the problem is that the unit of the callbacks is after the unit of the services, and there's no mention that it will be needed in the project. So I think it would be good to add that.
Yes, we've actually made that change already. So yes, you're right. You're right. We tell you guys to start the services section before talking about reentrant callbacks. So now that is fixed based on what you guys tell us, and that makes total sense. Yes.
Yeah. Then for the actions part, I created another action in the custom interfaces. I added a script to be able to control this. So inside it, I subscribe to the odometry topic, and in the callbacks, I would get the last odometry value and receive and extract the x and y and save them into a point variable. I would create a server, record the odometry, and in its callback, I would save in a list the first recorded one, and then at every second, I would get the last one and also store it in this list. And for the feedback, I would calculate the distance to the last point and add it to the total distance. And this would give the current total distance each time. And also at every step, I needed to check if a total lap of the environment is done by calculating the distance to the start point and checking if it's inferior to a certain threshold. Then this will be added to the wall following by applying to the action. This getting the result would give the list of the recorded points. The feedback would give the current total distance. And I added it to the main launch file, and I added the entry point to the setup.py, and that would be it. For this section, there are not really difficulties related to this section, but difficulties related to the overall behavior. I found that
Mhm.
it would be sometimes dependent on the initial position. It will behave differently if it's placed in initially in different points.
Yeah, 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 makes sense. And then you would have different situations in which to complete the lab, right? Is that what you're saying? Yeah. Okay. Well, thank you, Mariam. Really good presentation. So, do you mind stopping sharing your screen so I can ask you? Great. All right. So,
Okay.
congratulations, Mariam. Really nice presentation. I'm glad it
Thank you.
worked after a couple of tweaks there. There are certain things that are definitely I wanted to ask you a little bit more about. So, I was talking about this movement that it kind of went a little bit and then stopped, and then went a little bit and then stopped. In my mind, it looked almost as if there was like something that was making the program sleep for a certain amount of time. So, but you mentioned, right? You mentioned that this behavior did not happen all the time.
Yeah.
So let me ask you, in your node, in your ROS2 node, any of them, well, let's do the wall following node. Do you have
Mm.
something that specifies the frequency at which it spins? For example, there's a spin once command for the RLCA library. Do you use something like that to establish the frequency at which the node is spinning?
I didn't specify the frequency, but I think when I added the entrant callbacks, I modified the spin, and yeah, I
The
think
spin,
at that
okay.
point, yeah,
So that is
at that,
actually what it defines it. The spin, you're telling, do this every certain amount of times. So this that why am I saying this? Because this weird behavior that we maybe saw can be a bad luck between at the frequency at which this node is spinning and things like added sleeps you added during your program, or the frequency at which you're receiving the data that triggers the callback, right? So all of these things can make a difference. So it's just a matter of fine tuning these a little bit. So,
okay.
but I asked you also to see if you kind of had a good idea, and you do. So that's great. That's great. At the end, that's the point here. And the other thing I wanted to just mention is just to avoid confusions, because you mentioned, by the way, really great presentation, because I could see each part of the code. You said what it's doing, and then you put each part of the code there, so you can kind of put that in pieces. In my mind, it's a lot easier to understand. But you mentioned something that was, I just want to mention that it can confuse you. So you said that once you added the two nodes in the launch file, you were having an issue that then was resolved with the reentrant callback groups. So I want to emphasize the only thing that the launch file does is
Mhm.
running your nodes. It's as if you were in the terminal and you typed, ROS2 run, the first one, and then in the other terminal, ROS2 run, and then the second one. So, and the reenter callback, what it's there for, it's to avoid issues with the callbacks inside one of those nodes. It doesn't have to do with separate nodes. So what it does is it prevents your callbacks from sort of stepping onto each other. For example, in your, let's say, in your service server, in your find wall service, you are calling the service that will trigger a callback. The server
Yes.
has a callback that it gets triggered when you do raw service call, right? And then inside of that, you also need the callback of the LiDAR to keep working,
Yeah.
right? Because otherwise, you would start the service with the last
Yeah.
value of your LiDAR, and you would probably crash because, it's the same number over and over. But I wanted to mention that to separate those concepts in your mind, so you don't worry about reentrant callbacks related to launch files. They're separate things. The reentrant callbacks they can help you with just one node with no launch file. So I wanted to make that point because it is the toughest part of this course. And you mentioned that we had a big mistake in not introducing it early enough, which we have fixed. So thank you for letting us know about that. But yeah, those are the two comments I wanted to make. Other than that, you accomplished the objective very, very well. And I mean, it's a nice program that was concise. So I want to just congratulate you again, Mariem.
Thank you. Thank you.
All right. And for everyone else that is watching, this is what you can do with our courses. At the end of our courses, you can present your work to show us that you've actually taken something of value from our courses. And we provide you with a certificate that means something to us, because that means we don't give it to anyone. We give it to the people that take something learning away from this, like Mariem here. So I want to encourage you guys to do what Mariem did here in your ROS course projects and do them here in our real robots in order to keep your push learning. And that is it from us, you guys. So we'll see you guys next time for the next presentation. We have one in a couple of hours, so watch out for that. And Mariem, thank you very much again. We'll hope to see you again soon.
Thank you.
All right, guys. So that's it for us. We'll see you guys in the next one. Bye-bye.